Welcome to class, everyone. I'm still your favorite tutor, Mr. David. In this lesson today, we'll be learning a very wonderful and an interesting topic, systems of three linear equations. Systems of three linear equations. What are our objectives for today? Our objectives are solve linear systems with three variables by substitution method, and also check solutions to linear systems with three variables. So we don't just want to just solve, we also want to check if we are actually right or we are actually wrong. So we're going to be dealing with three wonderful examples in today's lesson. The first example I'll be giving you, or that we'll be solving today, is x minus 3y plus 6z is equals to 21, which is the first linear equation. I have 3x plus 2y minus 5z is equals to negative 30. Then I also have 2x minus 5y plus 2z is equals to negative 6. These are three wonderful equations, but where should I start from? While working with substitution method, the best thing to do, or the best thing for you, is to look for the alphabet where the coefficient is 1. When the coefficient is not 1, you end up getting a fraction, and that might make your work a bit complicated. And I'm sure you don't want your work to be complicated. So try to look for any of the equation where one of the variable have a coefficient of 1. Now, using equation 1, I can already see that the coefficient of x is equals to 1 using equation 1. So let's just label it. Label it, this is equation 1. It's going to be my equation 2, and this will be my equation 3. So I have my three equations. I have to use equation 1, where we have x minus 3y plus 6z is equals to 21. So what am I trying to do here? I'm trying to make x the set of formula so that I can impute both into equation 2 and equation 3 and then solve simultaneously. Try to make one variable the set of formula. After you've done that, impute it into the other two equations and solve them simultaneously. Very, very important. So if I'm trying to make my x set of formula, I have to move 3y and 6z to the right hand side. So my x will be equals to 21 plus 3y minus 6z. Very simple. Then substitute it into equation 2 and 3. Why 2 and 3? Simply because it was equation 1 I used to get this new equation. So it simply means anywhere you see x in equation 2 and equation 3, simply put 21 plus 3y minus 6z. So equation 2 becomes, let's put it there. So I have 3, instead of x, I'm going to be having what? 21 plus 3y minus 6z. Then we have plus 2y minus 5z is equals to negative 30. Then we go ahead and open up the bracket. That makes it to become 63 plus 9y minus 18z plus 2y minus 5z is equals to negative 30. I can choose to rearrange and also collect like terms at the same time. So I have 9y plus 2y minus 18z minus 5z is equals to negative 30 minus 63. So what is 9y plus 2y is 11y minus 18z and minus 5z. That will give me minus 23z is equals to minus 93. So I've gotten, let's call this equation 4. Okay, so equation 3 becomes, remember what we have before for equation 3, we have 2x minus 5y plus 2z, 2x minus 5y plus 2z is equals to negative 6. So we're going to replace our x with what we had before, which is going to give me 2, open bracket, 21 plus 3y minus 6z minus 5y plus 2z is equals to negative 6. So let's open up our bracket. We have 42 plus 6y minus 12z minus 5y plus 2z is equals to negative 6. So we can choose again to rearrange and collect likeness at the same time. So that will give us 6y minus 5y minus 12z plus 2z is equals to minus 6 minus 42. And that will help us to get y minus 10z is equals to negative 48. So let's call this the equation 5. Now we have equation 4 and we have equation 5. So what do we do? Solve equation 4 and 5 simultaneously. So what is equation 4? We have 11y minus 23z is equals to negative 93. And for equation 5, we have y minus 10z is equals to negative 48. Remember, we are working with substitution method, so I won't want to dive straight into using what we call elimination method. So let's still break down y minus 10z. So using y minus 10z is equals to negative 48. So my y will be equals to negative 48 plus 10z. So take this and throw into the equation 4. So anyway, I see y, I'll put negative 48 plus 10z. That makes it to become 11 into bracket negative 48 plus 10z minus 23z is equals to negative 93. So let's go ahead and open the brackets. We go ahead and open the bracket. So we have 11 times negative 48. That will give me a negative 528 plus 110z minus 23z is equals to negative 93. So at this point, what will I do? Collect like terms. I have 110z minus 23z is equals to minus 93 plus 528. And that will give me 87z is equals to 435. So what will be my z? Divide both sides by the coefficient of z. So my z is equals to 435 over 87. And that is equal to what? 5. So we've been able to get our z in the system of linear equation. So let's take this to where we have our y. Let's get y. So therefore, y will be, so we're going to work with y is equal to negative 48 plus 10z. So my y is equal to negative 48 plus 10 into bracket 5. So my y is equal to negative 48 plus 50. And that is equals to 2. Let's just draw a short line here so that we can actually find our x. Remember, initially we made a formula where we had x to be equals to 21 plus 3y minus 6z. Now we have our y and we have our z. So our x will be equal to 21 plus 3 into bracket with our y, which is 2, minus 6 into our z, which is what? 5. So it means I'm going to be having x is equal to 21 plus 6 minus 30. So my x is equal to 21 plus 6 is 27, and 27 minus 30 will give us negative 3. So therefore, our x is equal to negative 3, comma, our y is equal to 2, and our z is equal to 5. So we've been able to solve the first example under system of 3 linear equation using substitution method. Let's also solve the second example to see how good we are. Moving to the second example, we have three wonderful equations again. Let's label it. Let's call this equation 1. Let's call this equation 2. And let's call this equation 3. Remember what I told you? Always look out for the variable where the coefficient is simply 1. That makes your solving more easier. So I have equation 1 where my coefficient of y is 1, and I have equation 3 where my coefficient of y is also 1. So I can choose to use any of them. So using equation 3, we use equation 1 in the first question, so let's use equation 3 now. So using equation 3, we have 6x plus y plus 2z is equals to 9. So it means my y will be equals to 9 minus 6x minus 2z when I move 6x and 2z to the right hand side. So if I've gotten what my y is, input y into equation 2 and equation 1. So since we use 3 to derive what we have currently, then we have to insert it into equation 2 and equation 1. So therefore, equation 1 becomes, so let's see what equation 1 will become. So I have 7x, it was not x we have, this was y, plus, what is my y? 9 minus 6x minus 2z. Now, I know it's a bracket. Assuming it was a minus outside there, like minus y, then I have to use a bracket because y minus has an effect on other variables. But plus does not have any effect. That's why I chose not to use a bracket. But for clarity's sake, let's just make use of a bracket. But when I open the bracket, it has no effect. So plus 5z is equals to 27. So let's open the bracket. I have 7x because it's plus 1. When plus 1 multiplies everything, I have the same thing. So I have become plus 9 minus 6x minus 2z plus 5z is equals to 27. So from here, I can rearrange and also connect like them. So I have 7x minus 6x minus 2z plus 5z. You have to be very, very careful. Is equals to 27 minus 9. Okay, 7x minus 6x becomes x, minus 2z plus 5z becomes plus 3z is equals to 27 minus 9 becomes 18. So we have it as 18. Let's call this equation 4. Okay, now let's put it into equation 2 also. Equation 2 becomes, remember we have to put this into equation 1 and equation 2. So equation 2 becomes, I have 4x plus 3 multiplying the y. What is the y again? 9 minus 6x minus 2z. Then plus 5z is equals to 21. So let's open our bracket. I have 4x plus 27 minus 18x minus 6z plus 5z is equals to 21. So let's rearrange and also collect license at the same time. So I have 4x minus 18x minus 6z plus 5z is equals to 21 minus 27. And what is 4x minus 18x? That is negative 14x. Minus 6z plus 5z will be what? Minus z. And that will be equals to negative 6. 21 minus 27 is negative 6. They all have minus. So I can divide all through by minus. So let's put that here. Divide through by negative. That means I'm going to have 14x plus z is equals to 6. So solve equation 4 and 5 simultaneously. So we have x plus 3z is equals to 18, and we have 14x plus z is equals to 6. So I can use any of the two equations. Since I'm still using substitution method, I can use any of the two to start. So using 14x plus z is equals to 6. Make your z is the formula. Z is equal to 6 minus 14x. Put this into equation 4, which is this. So I'm going to be having what? X plus 3 into bracket 6 minus 14x is equals to 18. Let's go ahead and open our bracket. So I have my x plus 18 minus 42x is equals to 18. So rearrange and collect like terms. X minus 42x is equals to 18 minus 18. So my x, or negative 41x, is equals to 0. So what will I do from here? Divide both sides by negative 41. So x is equal to 0 over negative 41, which is equals to 0. So my x is equal to 0. Now I can go and find what my z is. Using z equals to 6 minus 14x. Remember, we made z the formula. So our z is equals to 6 minus 14 multiplying what? 0. So my z is equals to 6 minus 0, and my z is equals to 6. Finally, let's find the value of y. Finding y. Remember, what is our y? Our y is equals to 9 minus 6x minus 2z from beginning. So input your x and your z. So my y is equals to 9 minus 6 into multiplying 0 minus 2 into bracket 6. So input my y is equals to 9 minus 0 minus 12. And that will be equals to negative 3. So therefore, my x is equals to 0, my y is equals to negative 3, and my z is equals to 6. We've been able to solve another example under system of linear equation. 3 linear equation. Let's solve the last example under this particular topic. But before we dive into the third example, let's check if our answer is correct. You can also do this same method for the first example, checking if your answer is actually very correct. So let's go and input it into the equations that we have. If we check out the first equation, we have 7x. I'm using this color so that it will be different from what we saw. We have 7x plus y plus 5z is equals to 27. Now let's input it and see if we're going to get our answer. 7x means 7 times 0. So 7 times 0, we have 0. Plus what is our y? Our y is simply negative 3. Plus 5 is multiplying z, which is 6. So this is 0 minus 3 plus 30. And that is equals to negative 27. So you can see our answer is correct. We can also input it into equation 3, where we have 6x plus y plus 2z equals to 9. Let's see whether we'll get 9. So 6 times 0 is already 0, plus this is negative 3, plus 2 into bracket, and z is how many? 6. So I have 0 minus 3 plus 12, and that is equals to how many? 9. So you can see that our answers are perfectly right without any error or any blunder. Now let's move to the last example under this wonderful topic, solving systems of 3 linear equations. Here comes our third example, 3 wonderful linear equations. Again, look for the one where the coefficient of the variable is equals to 1. We have that in equation 1, where the variable of z is equal to 1. So let's make z the formula in equation 1. So using minus 5x plus 3y plus z is equals to negative 15. Let's go back and label it first. So this is equation 1. So don't get lost. Equation 2 and equation 3. So let's get the new one that we input into equation 2 and equation 3. So my z will be equal to negative 15 plus 5x minus 3y. So let's input both into equation 2 and 3. Input into equation 2 and 3. That's where we are heading to. So let's input it into equation 2 first. Remember, we are only changing what z is. So equation 2 becomes, so we'll go ahead and open the bracket. I'm going to be having 10x plus 2y plus 8 times minus 15. That will give us negative 120 plus 40x minus 24y is equals to 18. So rearrange and collect like at the same time. So I have 10x plus 40x plus 2y minus 24y is equals to 18 plus 120. That makes it 50x minus 22y is equals to 138. If you look at all three numbers, it can be divided by 2. So therefore, we divide through by 2. And that makes this become 25x minus 11y is equals to 2 in 13 is 6. Remember 1, and that will make it become 9, 69. So I have my equation 4. Let's go and get equation 5. So equation 3 becomes, input it into equation 3. Remember for equation 3 we have 15x plus 5y plus 7, what is our z again, minus 15 plus 5x minus 3y equals to what? 9. So I have 15 plus 5y minus 105 plus 35x minus 21y is equals to 9. Rearrange and collect like terms. So I have 15x plus 35x plus 5y minus 21y is equals to 9 plus 105. So this will make it 50x minus 16y is equals to 114. So therefore, divide through by 2 because 2 can divide. That makes this 25x minus 8y is equals to 57. So you have 25x minus 8y is equals to 57. Let's call this equation 5. So we can solve equation 4 and 5 simultaneously. Using 25x minus 11y is equals to 69. So it means 25x is equals to 69 minus or plus 11y. Input this into the second equation anywhere you see 25x. So instead of 25x minus 8y, I'm going to have 69 plus 11y minus 8y is equals to 57. So collect like terms, I'm going to have 11y minus 8y is equals to 57 minus 69. And that will give us 3y is equals to negative 12. So divide both sides by the coefficient of y, which is 3. So y is equals to negative 12 over 3, and that is equals to negative 4. So I've been able to get my y, so we can go ahead and get our x. So how do we get our x? Using 25x is equals to 69 plus 11y. So I have 25x is equals to 69 plus 11 into bracket minus 4. I have 25x is equals to 69 minus 44. What are we going to have here? 25x is equals to 25. So my x will be equals to 25 over 25, and that is equals to 1. At this junction, we can go ahead and get what the value of z should be. Now, at this point, using z is equals to negative 15 plus 5x minus 3y. We already have what our x is and what our y is. So I have my z to be equals to negative 15 plus 5 into bracket 1 minus 3 into bracket with our y, negative 4. So my z is equals to negative 15 plus 5 plus 12. And that is simply giving me my answer as positive 2. So therefore, my x is equals to 1, y is equals to negative 4, and my z is equals to 2. We can draw a line somewhere here just to check. Let's draw a line to see if our answer is fully correct. So, a simple line. So from here, I have, using the first equation, which is minus 5x plus 3y plus z is equals to negative 15. If I place my x, y, and z, then will I get negative 15? So I have minus 5, what is my x, 1, plus 3, what is my y, negative 4, plus my z, which is how many? 2. It makes it negative 5, negative 12, plus 2. And that will give us what? Negative 15. So it means if I try for the other ones, I'm still going to have the same answer. That brings us to the end of system of 3 linear equations, solving problems under systems of 3 linear equations. Watch out for the other lessons, as will be coming up every week with one lesson. Do enjoy the rest of your day.